Moving on to chapter 1, we're going to cover 1.2, which is going to be linear equations and rational equations. So not expressions anymore, equations. So we're talking about linear equations of one variable. So you're used to this probably y equals mx plus b. This is two variables. This is a linear equation in two variables. So we're talking about just one variable. So a linear equation of one variable x, it can be written in the form ax plus b equals 0. We usually call this a standard form. Where a and b are real numbers and a cannot be 0, because if it is, then, well, we're just saying b is equal to 0, which is not much for us. So examples of this would be 5x plus 7 equals 0, or 2/3 x plus minus 2 equals 0, or it could be -7/2 plus 3 equals 0, or it simply could just be 6x equals 0. Because nobody said 0 could, b couldn't be 0. We were just saying a couldn't be 0. So this one is still fine. So we want to work on generating what we call equivalent expressions. So we're kind of going to go through a little bit about simplifying and solving. So an equation can be transformed into an equivalent equation by one or more of the following operations: simplifying an expression by removing grouping signs and combining like terms, adding and subtracting the same real number or variable expression to both sides, multiply both sides by the same non-zero quantity on both sides of the equation, and then interchanging the two sides of the equation. So first thing we're going to do, when we can, is we're going to simplify. Then we're going to add and subtract real numbers from both sides of the equation until basically we get your x by itself. Then we're going to divide whatever's on that x, so then we can solve it. All right, so we have here 4x plus 5 equals 29. So what we would do was right here is that there's no simplifying to do. So the first step we're going to do is we want to isolate the x term. So because we have plus 5 here, when we want to move it, we're going to say minus 5. Now, if you remember with equations, these have to stay equal, so we minus 5 from the other side. So then we just have 4x is equal to 24. Then from here, what we would do is we'd say, oh, well, we want to get rid of this 4 here to get the x by itself. So we divide both sides, because if I divide one side by 4 to get rid of the 4, I have to divide the other side by 4. So then x is just going to be 6. And this is our solution. So we just need to go back and check it. So check it, just stick it back in. So we have x times 6 plus 5. And we want to see, does that equal 29 for us? Because that's going to be 24 plus 5, which will equal 29. So it checks out. Now if we look at b, b is 6x minus 7 equals 11. So in this case, we want to get the x term by itself. So we want to leave this alone for right now, but we have this 7 here, this constant. So we have minus 7. So we just add to counter that subtraction. So because we add 7 here, we add 7 here. So we get 6x is equal to 18. Now we want to get rid of this 6. So we divide by 6, and then we have to divide the other side by 6, meaning that x is going to be 3. So we just need to check that. So we have 6 times 3 minus 7. Well, that's going to be 18 minus 7, which is 11. So that checks out. So this is my solution to A. And this is my solution to B. So just try this on your own. You have 6x minus 7 equals 9, and then you have 5 minus 2x equals 11. All right, so for A, like I said, we would like to leave the term with the x alone first, because first thing I need to do is get rid of this constant. So we're going to add 7 to counter the subtraction. So we get 6x equals 16. Now we're going to divide both sides by 6, because when we get the 6 off the x, so x is equal to 16 over 6, which if we simplify that, so both of these are going to be divisible by 2. So we're going to get 8 over 3. So yes, you can get fractions as answers. Over here, so we see a little bit of a switch. We have the 5 minus 2x, but I can't touch this x term yet. So what I can do is I have this positive 5. I can subtract a 5 to counter it, leaving me with negative 2x equals 6. Now I have a negative 2 times x, so I can divide by a negative 2 to get rid of that, which is going to leave me with x is equal to negative 3. Okay. So we're going to amp this up a little bit. So we're going to solve some more linear equations. We're going to simplify the algebraic expressions on each side by removing grouping terms and like by removing grouping symbols and combining like terms. And then we're going to collect all our variables to one side and our constants to another, isolate the variable, and solve. So we just have been doing this the easy way. Now we're going to amp this up a little bit. All right. So I'm going to have to erase some of these answers after I get them. We'll make as much space as I can. Oops. I might fit them all in here. So we'll put A over here. So we should check our solutions. So we'll do that as well. So this is still a linear equation. 3 times 2x minus 1 equals 9. What we need to do is simplify. So we want to get rid of grouping symbols, if you remember, for simplifying. So I have to distribute my 3. So this is really 6x minus 3 equals 9. So now this is something that we've seen before. So if we want to figure out what x is, we're going to first, we want to make sure all my constants basically are to one side, but what we say is, I got this minus 3 here on the x term, so I'm going to add a 3 to counter it, leaving me with 6x is equal to 12. Then if I divide both sides by 2 if I divide both sides by 6 to get rid of this 6, then we're going to have x is just equal to 2. So let's do a quick check on that. So if I have 2 times 2, and then my x is going to be 2 minus 1, well, that's going to be 3 times 4 minus 1, which is going to be equal to 3 times 3, which is equal to 9, which is what we had right here. So that checks out. All right, make myself a little more space and cut off part of our problem here. So let's do B. So B is 4x plus 5 equals 2x plus 11. In here, we are going to do really what's like combining like terms. So I have a x term over here and I have an x term over here. I have a constant here and I have a constant here. So I'm going to rework it so my constants are one side and my x terms are on the other. So first thing, let's just do this. Let's move that 5. So we have this constant of -5, so we'll just move that first. So that's going to give me 4x is equal to 2x plus 6. Now, because the x term's here and the x term's here, I want the x terms just to be on one side and the constants just be on one side. So we have a constant here, no constant here. So it's this minus, this is 2x we need to move. So since this is positive 2x, we just subtract a 2x. And we just subtract it from both sides. So we get 2x is equal to 6. Now all we have to do is divide by 2 to get x by itself, and we get that x is equal to 3. So once again, if we go back and check it, so I'll put it on both sides. We're going to have 4 times 3 plus 5 is equal to 2 times 3 plus 11. So that is 12 plus 5 is equal to 6 plus 11. So that is going to be 17 is equal to 17. It checks out. All right, our very last one is going to be C here. So C, we're going to really just combine what we did in A and B here. So we have 2 times 5x. So I need to move my stuff a little bit. 5x minus 3 is equal to 7x minus 3 times x minus 8. So let's distribute this 2 across. That is going to give me 10x minus 6 is equal to 7x minus, let's distribute this 3 across, -3 times x, so -3x, -3 times -8, plus 24. Now we're going to combine like terms. We're not done simplifying here. So once I'm done simplifying, I have 4x plus 24 on the side. Now we can do like what we did in B. So put our constants on one side. So I'm going to move this 6 over here. So -6, add the 6. 10x is equal to 4x. 24 plus 6 is 30. Now we're going to move this 4x. So we'll subtract 4x here, subtract it here. So 10x minus 4x is just 6x. So we have 6x is equal to 30. Now if I just divide by the 6, so I can get x by itself, we get x is equal to 5. Okay. Technically, we should check this one too, but I'm running out of room here. So I might have to just tell you to believe me, but let's see if I can check it quick. So check 2 times 5 minus 3 equals 7 times 5 minus 3 times 5 minus 8. So this is going to be 2 times 25 minus 3, so 22, sorry. This is going to be 35 minus 3 times -3. So this will be 44. This will be 35 plus 9, which will be 44 equals 44. So that one checks out. So take a moment and work on worksheet number 2, A and B, and just solve these linear equations. All right, so let's do A. Actually, let me make the screen just a little smaller so there's a little more room here. There we go. Sometimes the stuff just doesn't catch when I do it. There we go. So I'll put A on one side and B on the other. All right, we'll do A over here. So we have 3x plus 5 minus 2x equals 6x minus 10. So if we simplify both sides, this side will simplify because we've got like terms into x plus 5, and this will be 6x minus 10. So it's up to you what you want to move first. So we could minus the 5 or we can add the 10. So we haven't done it this way, so let's add the 10 first. That's going to give me 6x is equal to x plus 15 when we add the 5 and the 10. And then from here, I can subtract this x. So I end up with 15 is equal to 6x minus x, 5x. So in this case, x is on the other side, but that doesn't matter. Still have to divide by 5, and I get 3 equals x. So if you end up like this and you do not like that answer, you just switch it around to say x equals 3. Now if we do b, we have 3 times x plus 2 minus 8x equals x plus 9. So we distribute. We've got to simplify both sides. So we get 3x plus 6 minus 8x equals x plus 3. Then we have 3x minus 8x is minus 5x plus 6 is equal to x plus 9. Okay, so I am going to subtract the 6x from both sides. So the constants are on one side. So we get x, 9 minus 6 is x plus 3, minus 5x on this side. Then we'll subtract this x to move it, and we'll get minus 6x equals 3. Now we just divide by negative 6, and we get x is equal to negative 1/2. Now let's say we have a linear equation that has denominators. So this is technically a linear equation. It's just representing a bunch of fractions. So we just learned something earlier, an LCD. We can clear the fractions. So we have 4, 14, and 7. So I'm going to put my LCD over here. So 4 is just 2 times 2. 14 is just 2 times 7. And 7 is just factors into 7. So my LCD, so if I keep this 2, then I don't need this 2. And if I keep this 7, I don't need this 7. So I want to just make sure that I get the 2 times the 2 times the 7. So that is going to be an LCD of 28. Oh, I think we saw that one before. So what I can do here is I can multiply both sides of this expression by 28. And what we're going to see here is that we got 28 times x minus 3 divided by 4 is equal to, and this one's going to distribute, to 28 times 5, just leave it as is, over 24, or sorry, over 14, minus 28 times x plus 5 over 7. So my 28 divided by my 4 is just going to leave me with a 7. So I have 7 times x minus 3 equals 28 divided by 14 is just 2 times 5. And then 24 divided by 7 is just 4. So that's 4 times x plus 5. So what we're doing here is we're picking a number. This is 28. We know that 14, 4, and 7 can all divide into 28. So we're using it as a multiple so that we can eliminate these denominators. So now we'll just go back to what we've done before. Simplify, so distribute the 7. 7x minus 21. 2 times 5 is 10. Distribute this 4 minus 4x minus 20. So we got 7x minus 21 is equal to minus 4x minus 10. So 10 plus 20 minus 20. So x minus 21 minus 4x minus 10. So let's add one of the constants. So we'll do the 21. So I have 7x is equal to minus 4x plus 11. then we can add the 4x to both sides. And we're going to have, well, 11x equals 11. So x is equal to 1. Oops, sorry. Let me put that little step in there. Minus 11, so we get the x by itself. And then we get x is equal to 1. All right, so this moves us into a rational equation. So technically, well, we had rational equations before, but this is a different kind. So x is on the bottom. Let's just make a little note here. My domain, one thing x cannot be is 0 because it'll be 5 over 0 here, which was undefined, and then 1 over 0 here, which is undefined. So we need to find that LCD. So we have 2 times x. We have 18, which is just 2 times 3 times 3, or 2 times 9. And then we have 3x, which is 3 times x. So essentially, because we share this 3 once, my LCD is going to have the 2. Then we'll keep, oops, let me go back. I just realized I missed another one of them. So I had there. So my LCD is, remember, keep the ones of the first one, so 2x. So once I have the 1, 2, I don't need another 2. And then once I have the x, I don't need another x. And then I have 3. So once I use the 3 in this denominator, I don't need this 3. And then I just have an additional 3. So that's going to be 18x. So we're just going to multiply everything by 18x. So we're going to have 18x times 5 over 2x. We're going to have 18x times 17 over 18. Then we're going to, let's go back. I missed my hex. We have 18x times 17. I know I said it, I didn't write it, over 18. And then we have the 1, we're going to multiply that by the 18x over 3x. So everything got multiplied by 18x. Sorry, 18x. So 18 divided by 2, that's going to leave you with 9. The x's eliminate, so we just have 18 times 5 here. 18 times divided by 18, the 18's gone, so we're just left with the x and the 17. Here, 18 divided by 3, it's going to be 6. The x's eliminate, so we just keep the 6. So now, to simplify that, 45, 17x minus 6. So if I just add 6 to the other side, we're going to have 51 equals 7x. So let me just double check this. I'm pretty sure that 51 divided by 17 is 3, and it is. So we can divide both sides by the 17 to get the x alone. So we get 3 equals x, or you can say x equals 3. So the reason I checked my domain is I want to make sure I have a solution that's okay. So this solution's in my domain. Something we'll do a little bit more on in the future, but starting now, we'll just kind of look at that. So the one thing that I could not have is x couldn't be 0. So x is 3, so we're okay. That is the solution. All right. So for A, we have a 4 and a 6 in the denominator. So my LCD, I think, should be 12 because I know that 4 divides 12 and 6 divides 12. So we're going to have 12 times the x plus 3 over 4. And then we'll have the 12 times x plus 6 over 4. So multiply both sides by that 12. So we're going to do this a little differently, but I have 12, and then I know I'm going to divide by this 4 here. So I know that's going to leave me with 3. I have this 12 divided by 6, so that's going to leave me with 2. So we should have 3 times x plus 3 equals 2 times x plus 6. So I would distribute that. That is 3x plus 9 equals 2x plus 12. So if I subtract 9 from both sides, I'm going to have 3x is equal to 2x plus 3. And subtract 2x from both sides, I'm going to be left with x is equal to 3. Okay. B now. So let me cut off a little more of this edge here. Make sure I have enough room for this. So for B, we see that we have a 2, a 4, and a 2. So here my LCD would just be 4 because I know 4 is divisible by 4 and 4 is divisible by 2. So the only thing we need to change is this 1/2. So, or sorry, I'm thinking for adding. We're not adding, we're clearing the fraction. So we just need to multiply everything by that 4. So we'll have 4 times 3x over 4 plus 1/2 is equal to 4 times 2x minus 3 over 4. So remember, this 4 has to distribute, so that is actually going to be 12x over 4 plus 4 over 2 is equal to, we'll just say 4 times 2x minus 3 over 4. So we're left with a 3x here plus 2, and then here we're just left with the 2x minus 3. So let me subtract 2 from both sides. 2x minus 5 equals 3x minus 2x from both sides. And we have x is equal to negative 5. Now C, we are going to have, it's going to be a little more complicated because, well, not too much. We see that we have t plus 3, we have t, and we have t times t plus 3. So if I have t times t plus 3, what we're going to see here is that t plus 3 will divide into the LCD, t will divide into the LCD, and t times t plus 3 will divide in that LCD. So we want to multiply everything by t times t plus 3. So if I do that, I'm going to have and make myself the room for this. So somebody's going to write this. And you can multiply an entire equation by something. This is not something you see often, but you can do this. Just to save room. So I know this has to distribute to everything in here. So I'm going to have t plus 3 over t plus 3. I'm going to have 2 times t plus 3 over t is equal to 3 times t plus 3 over t plus 3. Oops. So we start canceling things that are the same. So we get a t here, plus 2 times t plus 3 equals 3. So if I distribute that 2, we have t plus 2t plus 6 equals 3. If I simplify further, I have 3t plus 6 equals 3. So just subtract 6 from both sides. We get 3t equals negative 3. If we divide both sides by 3, we get t is equal to negative 1. And then just as a side note here, just to notice, so the domain here, before we started actually going through the solutions, my domain was that t could not be 0, well, it could not be negative 3 or 0. And since my solution isn't either of those, we do have a definite solution here. So only when you have the variable in the denominator do you need to check to see that it's in the domain. So sometimes when we go through an equation, whether it's linear, whether it's rational, or a variety of other ones, we could have a situation where we end up with a finite number of solutions. Means like we have it's not infinite. We have a certain number of solutions, like we have 1 solution or 2 solutions, or we have 10 solutions. There is a possibility that our solution is going to, or we'll have infinite amount of solutions. There's an infinite amount of numbers that could work for us. And there's a possibility that nothing is going to work for us. So an equation that is true for at least one real number, but not all real numbers, is going to be called conditional. An equation that is true for all real numbers, so infinite solutions, is called identity. An equation that is not true for any real number is called an inconsistent equation. So we want to figure out, what do we have here? Do we have something that's identity, conditional, or inconsistent? So what we're going to do is we're going to try to solve this, and we're going to see what goes wrong. So if I start simplifying, I get 4x is equal to 4x minus 4 plus 3. And we get 4x minus 7 is equal to 4x minus 1. So usually I see most people go by this, that, oh, well, now I just have to add the 7 to both sides. And I get 4x is equal to 4x minus 1. Well, I can subtract this 4x, and then, I have 4x minus 4x. That means I have 0 is equal to negative 1. Now, can 0 be equal to negative 1? Well, no, it can't. So this is a sign that we have what we call an inconsistent equation. What this is telling me is that it doesn't matter what I do, I'm not going to have a solution. Because if you look right here, I have 4x minus 7, I have 4x minus 1. Whatever x is, we have that, we're subtracting 7 from one side and we're subtracting 1 from the other side. It's never going to be equal, no matter what we pick. So when you have an inequality, that tells you that it's going to be inconsistent. So when you see you get an inequality like this, that means it's inconsistent. We have no solutions. Now, we'll see what happens here with a little different equation. So we have this 7x plus 9, and the other side, if we distribute, we end up with a 9x plus 1 minus 2x. Oops. So distribute that 9, so it'd be 9x plus 9. Oh, why did that? 9x plus 9 minus 2x. So if I simplify, I have 7x plus 9 equals 7x plus 9. So some of you here might see what's going to be going on, but let's keep going. If I subtract 9 from both sides, I have 7x equals 7x. If I try to subtract 7x from both sides, we get 0 equals 0. So usually a lot of times this is 0 equals 0. We see here, we see here. Both sides are always equal. So when both sides are always equal, that's going to tell me that it's going to be equal for everything. So we have infinite, or every x value is a solution. All real numbers are a solution. Sorry, it's trying to glitch a little bit here. So that means what we have is a identity. So the term, we use the term identity also as you go forward, you'll see in other classes. So your definition will expand a little bit. In trigonometry, we have identities too, but that's all it is. An identity is an equation that is always equal. Its set of solutions is infinite. So you already know what conditional looks like. Everything we had before was conditional. We had one solution. So here on worksheet number 4, we have A, B, and C. Figure out which one is conditional, which one's an identity, and which one is going to be inconsistent. Alrighty, here we go. Oops, just closed down my writing tools. All right, so if we look at A here, so we'll start simplifying here. So I could distribute this 3 across, and I'm going to be left with 3x minus 6 minus 2x. I'm going to put A over here. We have a little bit more room. So A, if I start simplifying it, I get 3x minus 6 minus 2x equals 6x minus 5x plus 5. If I simplify further, I'm going to get x plus 5, and then over here, I'm going to get x minus 6. So from here, you probably already can see, I'm going to keep going. So plus 6 is going to give me x equals x plus 11. I'm going to subtract x from both sides, and I get 0 equals 11. So 0 cannot be equal to 11. That doesn't make any sense. So we have an inconsistent system, or inconsistent equation. And like I said, that just means we have no solutions. Now, if we look at B, I can fit B over here. So B, we have 2 minus 5x equals 1 minus 2 times x minus 2. If I start simplifying, I have 2 minus 5x equals 1 minus 2x plus 4, which is going to be 2 minus 5x equals 4 minus 2x. Oh, sorry, 5 minus 2x. Well, let's see. We start solving here. So let's subtract the 2 from both sides. So we have minus 5x equals 3 minus 2x. Let's add the 2 to both sides, 2x both sides. We get minus 3x equals 3. Divide both sides by negative 3. And we get x is equal to 1. So this is going to be consistent. We have one solution, which means that we have, or not consistent, I'm sorry, we have a conditional. It says consistent, but it's going to be conditional. So that's an equation that works sometimes. And then C, let's see over here. So C, we have x over x minus 2 plus 1/2 equals 2 over x minus 2. So LCD would just be 5 times x minus 2. So I multiply everything by that, we're going to have 5 times x minus 2 times x over x minus 2 plus 5 times x minus 2 over 5. And we're going to have 5 times x minus 2 times 2 over x minus 2. So we're going to be left with 5x plus x minus 2 is equal to 5 times 2. So we end up with 6x minus 2 equals 10. So if we add, we end up with 6x equals 12. We divide by 2, we're going to get our 6, we're going to get x is equal to 2. So once again, that one's also conditional. So we don't have any that are infinite solutions here. All right, so one of our last problems is just going to be some application problems. So now that we know how to solve linear equations or even rational equations, we can solve some application problems. So persons with a low sense of humor have higher levels of depression in response to negative life events than those who have a high sense of humor. This has been researched quite a bit, apparently. This can be modeled by the formula. I don't know how true the formula is, but it can be modeled by the formula D equals 10x over 9 plus 53 over x. In this formula, x represents the intensity of negative life events, and D is the average level of depression in response to the event. If the low humor group averages a level of depression of 10 in response to negative life events, what is the intensity of the event? So we know what D is. We know D is 10. We want to know what is X. So if we take D equals 10x over 9 plus 53 over 9, and now we say, well, D has to be 10. So we have 10 equals 10x over 9 plus 53 over 9. So we don't like these 9s, right? So all I have to do to solve for x, or to help me solve for x, is just multiply 9 both sides. So we get 90 is equal to 90x over 9 plus, we'll leave it like this, 9 times 53 over 9. So 90 is equal to 10x plus 53. So let's subtract 53 for both sides. So that should leave me with 37, right? Second, 7, 1, 2, 3, 4, yep. And then if we just divide by 10, we get x equals 37 over 10, or 3.7. So the intensity of the life event, whatever that would mean, is going to be 3.7. Sure, I got stuck there. So worksheet number 5, a state's mortality rate from skin cancer increases. I don't know why it's doing that. It's supposed to increases as the latitude of the geographical center of the state decreases. So the closer the state is to the equator, the higher the mortality rate. This can be modeled by the formula M equals 1,946 over 5 minus 299 over 50 L, where L represents the latitude of the geographical center of the state, and M represents the mortality rate of skin cancer in deaths per 10 million. Well, I think as was okay, as deaths in 10 million. What is the latitude of the geographical center of the state? And if the what is the latitude of the geographical center of the state if the mortality rate is 204 deaths out of 10 million? So this right here, that's the number you have to worry about. Don't worry about the 10 million. So take a moment and work on this question. So we have the M, our mortality rate is 204. So our equation that we're working with is going to be 204 equals 1,946 over 5 minus 299 over 50 L. Oops, L. So pretty sure that my LCD in this case would just be 50 because both 50 and 5 divide into it. So I just have to multiply both sides of the equation by 50. Okay, so 50 times, 50 times 204 is going to be 10,200. So this 50 is going to divide by this 5. So that's going to leave me with a 10 times 1,946. And then this 50 gets divided by this 50, leaving us with negative 299 L. So now we have 10,200 is equal to, so if we multiply that, that's going to be 19,046 minus, let's try this, 19,460 minus 266. Sorry, 299 L. So we'll subtract the 19,460 from both sides. We get negative 9,260 is equal to negative 299 L, meaning when we divide both sides by negative 299, what we're going to get is, if we do this division, that's going to be approximately 30.97 equals L. So what we have here is that if the mortality rate is 204 per 10 million, then that means that the state's center of its geographical center is going to be 30.37 degrees latitude. And believe it or not, this is actually for the state of Texas.